Okay, I'm live. Hello everyone and welcome to our next CEO's CodeTalks. This time we are having an event in person. That's great. We also have some online guests, so hi to everyone. So for those who don't know, CEO's CodeTalks is a community event that CEOs organize as a way to share our expertise and to give back to the community. So this time we are in Kragujevac, in Serbia, and today we have our colleague Miloš Slavić, who will present gRPC with service mesh architecture. So pretty hot topic with great things to talk about. So after that, if you have any questions, so both of you in person and online audience, you can post your questions, and later we'll have a lion talk, which is kind of a discussion that we'll have a panel discussion after the presentation. So without further ado, Miloš, please continue.
Okay. Thank you for the intro. I will talk about gRPC and service mesh infrastructure. As Miro already said, it's gaining popularity. So today I will talk about what is gRPC, what's the technology below the hood, proto-buffers. We'll see what's good and bad with gRPC, and I must compare it with WCF because Microsoft is pushing gRPC forward, and there are some recommendations that I will mention. Then I will talk about gRPC and JSON transcoding. We will also see what's the service mesh and how all of that fits together with gRPC. And I will focus mostly on Istio service mesh because I use it every day, mostly. Okay, what is gRPC? So Google had a problem with internal communication between services, and they needed a solution for that problem. So they invented gRPC they invented the protocol buffers to support faster communication. Under the hood, gRPC is using the HTTP2, which is a lot different than HTTP1 protocol. Other than that, Microsoft supported gRPC in .NET Core 3.0, and it continues with development and improvements on that field. Okay, let's move to protocol buffers. So, also known as protobuf, it is a data transfer mechanism that Google invented, which is using binary data, and it's very fast and very small comparing to JSON, for example. For defining the whole communication between services, we need to define messages, enumerations, and RPC services. So those are defined in .proto files, and there is no other variation of those files. It's always proto, and you will be able to see easy and notice that in other projects. So in order to support protobuf fully, Google also provides us with Proto-C compiler, which is able to generate source code for all major browsers, and that means that we can build services and clients, including mobile applications, so Android and iOS, with gRPC communication. We don't need HTTP anymore for those clients. The important thing with protobuf is that it doesn't support compression, but there is a way to enable it on application level. So that means that we cannot use gzip or other compression methods that easy on web servers. So we need to implement those in code. There is a problem with deserialization of large objects. So the recommendation is to make small chunks of objects and send them via streaming feature of gRPC. And I will tackle on that later. Okay. First thing, we need to define the models in our protocol buffers. So for that purpose, we use a message, and the message is pretty much same as classes in C#, and we have field types. We actually define field types, and there is one very important thing, and it is related to protobuf itself. It is required to set a positional unique number to each field. So those are 1, 2, and 3. Also on enumerations and on other messages, we always must define a unique number because it is used for serialization and deserialization of messages in protobuf. We can also reuse protofiles, import them, and just define message in one place and use it on 10 other places in our code. Protobuf messages also support nesting, same as classes in C#. So inside of a message, we can define another message, which is not available outside of this message. So in order to use this message outside, we need to specify order.orderItem. Otherwise, it's not available. Also, there is a support for collections, and we define them with repeated keyword. In the background, this will create a generic repeated fields collection of T, in this case of order item model. When we define models, we need to define the communication contract, and we use those models in those contracts. So here we have a simple RPC service defined. So keyword service is required. The method starts with RPC keyword, following the name, the request model that we will use. In this case, it's create certificate message with fields name, employee, and completeness. After that, it's required to use a return keyword and define the response message that this method will return. In this case, it's create certificate reply. Okay, so we need to compare protobuf with JSON, because JSON is very widely used, and I need to show you why it's much better, why the protobuf is much better than JSON. On the left side, we have a certificate model message containing 4 fields, and here we have JSON representation of that message. That message contains 52 bytes. It's very small message, but protobuf can do it better. Here comes the unique number that we define in protobufs. So it starts with 08, and after each field it will increase, and it will define the position in byte array for the serialization process. When this message is converted to protobuf, it will only contain 10 bytes, so it's 5 times less. Okay, every technology has its own good and bad things. So on gRPC, the good things are binary data format. It's really fast and produces really small payloads. Then we have gRPCs using HTTP 2 protocol, but it can fall back to HTTP 1 if the HTTP 2 is not available on client or server side. So we still have that backward compatibility. Then we have multiplexing. We can send multiple messages over the same channel, and that is the thing that separates gRPC from HTTP protocol. It is very buggy to use it in HTTP 1, and most of the time it will block the channel. In gRPC we have bidirectional streaming, which means that we can send small payloads from server to client or vice versa. The main thing with gRPC is that it is language agnostic, meaning that we can use it in any major language. C#, Java, Golang, every major, it has code generator. Okay, so the bad things. The problem is that gRPC cannot be hosted on Internet Information Services web server. So there is a recent update on Microsoft documentation stating that it is possible on Windows Server 2022, but they also require some higher build numbers, so you will need all of the updates on Windows Server. Another issue is hosting on Azure App Service. The main reason is that Azure App Service is using IIS in the background, but there is a new alternative. It is not available in all regions on Azure. It's called Azure Container Apps, and it allows us to run Docker containers in Azure directly without any orchestration. The biggest thing with gRPC is browser support. There is none. So we cannot use it for AJAX calls, we cannot communicate with any gRPC service, mainly because browsers do support HTTP 2, but the problem is the protobuf. So protobuf is not standardized technology, So browsers cannot rely on that functionality. So that's the main reason why it's not supported. Also a big thing, HTTP caching. It is not possible because of the connection in HTTP2. When we use HTTP2, it is actually creating a channel. So in HTTP1 we have connection handshake and connection terminates. In gRPC that connection stays open and we basically just exchange the messages on both ends. To overcome HTTP caching, we can do it on application level, on our servers or clients. It's on developers. At the beginning, when you dive into gRPC, there are a lot of terms, a lot of strange things that you're not common with. Like in REST, we all know REST, it's easy, we just define C# classes, expose the controller and it works. In gRPC, it's not like that. We need to define a data contract, and after we define a valid data contract, we can move to developing the code for it. Okay, I already said that Microsoft gave the recommendation for WCF developers to move to gRPC. This, for some users or developers of WCF, this can be a very big step. Also, a lot of enterprise companies and corporations are using WCF, so it's not that easy to just replace it in one day. Here I will cover the differences between WCF and gRPC. The main one is the message itself. So on WCF we use HTTP 1.1 and those messages are human readable. It's JSON or SOAP. On gRPC we have HTTP 2 connection, but the messages are in binary format, so they are a lot smaller and they are not readable. I already mentioned the issue with multiplexing. It also applies to WCF because it's using HTTP 1.1. There is a problem with web browsers. When we issue multiple parallel requests over HTTP1, there is a problem with head of line blocking, meaning that the first request will block the whole queue of requests until it receives the response. On gRPC we don't have that. We have multiplexing built into HTTP2, so it works without any hacks or workarounds. On interoperability side, in my experience, generating code that will consume WCF service is not always a nice thing, let's say. There are commonly, very common defined bugs in those generated code. On the gRPC side, we have a Proto-C compiler that can generate code for all programming languages, and they are fully tested, and most of those languages are covered by Google and the community. It's not the community itself. Another big thing in era of cloud computing is hosting. WCF can be only hosted on Windows. There are some efforts to host it on Linux operating system, but it's not that easy, and you need to use mono libraries or Wine, and it always produces some side effects that you don't want, especially in your production environment. On the other side, we have a gRPC that runs everywhere, mostly because it's supported by all major programming languages. We can compile code for every operating system, for different platforms, and even for different CPUs. It can also work on ARM-based processors. Both of these technologies have streaming capabilities. On WCF we have full duplex, and on gRPC we have a thing called full bidirectional streaming. Encryption is configured differently. On WCF we need to define it on binding level in code or application configuration, while on gRPC side we use HTTP2. So it's not our responsibility as developers to set up HTTP2 TLS certificates and all the things that it requires. On WCF there is support for distributed transactions. Those transactions are not possible on cloud, so because you need Microsoft Distributed Transaction Coordination, which is available on Windows servers and Windows operating system. On gRPC side, we don't support that. There is no support for distributed transactions, and mainly because gRPC is invented with microservices point of view. So in order to have distributed transactions, you will need to implement some Saga pattern or routing slip or some similar pattern, but it will need to be done in code. Okay, WCF has many communication options. We have different bindings, and the closest binding to gRPC connection is NetTCP. It's, let's say, on lower level than other bindings. It's on socket level, so it's also using smaller messages and binary format. So it's, let's say, equal to gRPC. But there is one drawback. It is only supported on .NET clients and servers. On the gRPC side, we can use gRPC on all platforms, all languages. HTTP protocol on WCF, it is text-based. It's using SOAP for a wire format, while on gRPC it's HTTP2 with protobuf. Next is named pipes. this is a Windows-specific feature, and it is not available in gRPC mainly because gRPC relies on TCP connection, and it is not bound to any operating system. This can be, let's say, overcome. We can overcome this with Unix domain sockets. .NET Core supports connection to Unix domain sockets, and they are also available in Windows operating system. I think a year ago or two, the support was added. Also, here we have Microsoft Messaging Queue, which is only supported on Windows operating systems. gRPC does not have any support for any messaging queue, so developers need to implement communication with Azure Service Bus, RabbitMQ, or Kafka, or any other message bus or event queue, depending on the need. The last one is Web HTTP, mainly JSON and REST APIs. On WCF, that is implemented with Web HTTP binding, but gRPC, as already said, does not support communication with browsers. To work around that, there is a thing called gRPC to JSON transcoding. It is converting JSON requests to gRPC, and vice versa, converts gRPC responses to JSON. Okay, to enable this feature, we need Google's API protofiles, and they need to be imported into our project in C#. So that part is a bit harder to do, and there is support in methods for annotations. Actually, it's option, but it's something like annotation. It does not affect the functionality of the gRPC. It's just something that we can add and enrich our methods. For gRPC and JSON transcoding, we need to define a method that we will use. It's post, and we need to define the REST path that will be used. Body parameter with asterisk means that we will take the whole create certificate message into consideration for JSON transcode. It's hard to set up, but you only set up that one time in your project. You don't need to do it very often. Another big thing is that gRPC JSON transcoding is not available in .NET itself, so you will need some kind of proxy. The proxy that we used is L7 proxy, meaning that it's protocol aware. So when it sees gRPC, it knows how to proceed with those requests, and we used Envoy proxy for that purpose. All of this, actually, those annotations will be needed, but the setup that is a bit harder will not be needed in .NET 7, because Microsoft is adding a new feature to gRPC. It's called gRPC JSON transcoding. So we will only need to specify those annotations, and we will not need proxy anymore. it's not visible here, but it's github.com/demo/hr. You can see the sample there, how to set up this, or just wait for .NET 7. Okay, let's move to Service Mesh. Service Mesh is infrastructure layer that is responsible for the network and controls the communication between services. The main issue here is that Kubernetes, which is very commonly used for large deployments, does not have advanced networking functionalities. For that purpose, we use Service Mesh because it has traffic management, it has built-in observability, and also has security. The Service Mesh is composed of two things: control and data plane. The control plane has one job: accept the configuration and distribute that configuration to data plane. It also has service discovery. It's something like internal DNS server. It is actually taking all the recorded services in Kubernetes and keeps its own registry. So using that registry, it can forward the requests and also distribute the configuration. On data plane, we have sidecar proxies and our own workloads, our deployments. Sidecar proxy is the proxy that runs side by side with our application. Kubernetes has workload model, let's say, named pod. Pod can run any number of containers. So it's not like Docker where you start one container. In Kubernetes, you can start many containers in one pod, and that is the smallest unit of work. Sidecar proxy, the main thing that it does when it starts is overwriting IP tables. IP tables is Linux firewall, and proxy sidecar will remove all entries in this firewall, and it will actually block any connection to your pod until the sidecar is fully up and running. So, meaning that when it goes up, it can control traffic, get new configuration from control plane, etc. The very nice thing with sidecars is that they collect logs, traces, and metrics. Okay, there are many vendors for Service Mesh, but I'm used to Istio and I like it. So I will continue talking about it. I just want to point out the important difference that Istio has comparing to other service meshes. It is a gRPC to JSON transcoding. That's the feature that we mostly needed, and all of the other features are available in in all other service meshes. So that's the main reason for using Istio. Okay, let's see what Istio has. First thing, traffic management. Istio uses Envoy for sidecar proxies. So it has under the hood, so it has layer 7 proxy support. It's protocol aware. Other than that, it has custom routing rules. Those rules can be defined with regex. Also, they can be very simple, like we had on previous slides for gRPC transcoding. Istio has ingress and egress controllers. Those control what comes in to the mesh and what comes out. So the whole network layer is controlled and traced. Important thing is integration with Flagger. Flagger is continuous deployment tool that can fetch metrics from Prometheus and other metric servers, and it decides if new version of the service should be released or should be rolled back to older version that is stable. We can connect multiple Istio service meshes into one, and that capability is called multi-mesh. When we do a multi-mesh, we are using MTLS for communication between those service meshes. So we get communication in the mesh that is encrypted, and also we have communication out of the mesh, actually between the meshes, that is also encrypted on both sides. Other than that, we have outlier detection, rate limiting, circuit breaker. Those are the things that we do in code, usually using a NuGet package called Poly. When we use Istio, we don't need this package. We can just define outlier, rate limiting, retries, timeouts. We can define those in configuration for sidecar proxy. Okay, from security perspective, Istio control plane is capable of rolling out new certificates and distributing those certificates to all sidecars. So that's the main mechanism behind the neutral TLS. That is a very good feature of Istio. Other than that, we can use policy-based authorization. From my experience, policy-based authorization is for some simple cases where we want to check, for example, if logged-in user is manager or employee, or so it's very minimal, and we cannot do a lot with it. But Istio has external server authorization, meaning that we can, let's say, outsource the authorization feature to some other service. There are services that have implementation for this interface, and one of them is Open Policy Agent. It's short OPA. With OPA, we get something like a programming language for authorization policies. And we can do much more complex things with OPA, like checking if parameter in body of the request is equal to some value, or checking the headers and combining that with body data from the request. Those kind of things cannot be done with policy-based authorization. So it can be done with OPA. If you have complex authorization and you need to support it, definitely go with OPA. It can also be unit tested, and it's pretty fast. It doesn't require any additional dependencies for building. It's pretty straightforward. Other great thing with Istio is observability. The sidecars will collect metrics, collect distributed trace, actually just collect the traces, but take the headers from the request and all report to distributed tracing server that will combine all of those traces into one constant flow. Also, Envoy proxies, the sidecars, have access logs. You need to be careful with those access logs because it will log every request, all metadata, so headers are included, and some processing things that come from Envoy. Just use it when in special cases, when you need to debug something. It can also be exported to Elasticsearch, Datadog, or other log servers. The last thing, and probably for developers the best, is extensibility. Since the Istio is using Envoy proxies under the hood, it is actually taking the feature of extensibility of the Envoy, and in Envoy we can define Lua scripts that will change request, change response, or we can take requests and responses and change the structure of them directly with those Lua scripts, or much better solution, use WebAssembly. Unfortunately, you cannot compile .NET code to WebAssembly. It is only available for browser usage for Blazor, but hopefully we will get some support soon to just build the WebAssembly library. Until we get to that feature, you can use C++, Golang, or Rust. Okay, let's move to the demo. Okay, the first thing that we get with Istio, but it's like an add-on, but Kiali is mainly developed to support Istio as a service mesh. Okay, let's explain. It's not very okay. In order for requests to come in the service mesh, we must define the ingress gateway. That's the entry point to the service mesh. When it gets to the service mesh, Istio will use service discovery to route that request to a specific service. Here we can see also that this connection from Istio Ingress Gateway to other services here is encrypted, so we have MTLS between Ingress Gateway to other services. Also, here we have some requests coming to employee search BFF. That is some workload that I deployed. This workload is connecting to employee and knowledge service in parallel. So it will produce requests to both services. All of that communication is encrypted with MTLS. Okay, the next thing is that we can see the graph for each service, and we can see how many requests we can serve, and also how did that request ended, where it ended. So, like on the same graph, we have employee search BFF that goes to employee and knowledge. You can also enable more statistics on these graphs, but there are some lags when you do that, and same like debugging. You need it when you debug. Okay, on traffic, we can see who is this, where is this employee search BFF communicating? It is communicating with knowledge and employee services, environment direction, and it receives requests from Istio Ingress Gateway. Kiali also allows us to see logs from our applications, from I cannot see it for some reason. Also, it should include sidecar logs that we can dive in directly from UI. We don't need connection to Kubernetes to debug it. Also, sidecars report metrics, and we can dive into the metrics and see where are our bottlenecks and weak points, where we lose time. Actually, just the best thing for detection of slow services, possibly places for deadlocks, etc. There are a lot of things that you can do with metrics. We have in Kiali, we have metrics in both directions, from Ingress Gateway and from this service to other services that we connect to. The very best thing about Istio, in my opinion, is distributed tracing, especially when you have some gRPC service that connects to 5 other gRPC services, and one service fails, just shutdowns, rejects all requests. You need the fast way to find that service and fix a bug, an issue, maybe it's configuration of sidecar. You need to know which one is fast. That can be done with traces. So, sidecars are reporting traces. It can report traces to Lightstep, Zipkin, Jaeger. I think there are more tracing servers that can get the data, but the mostly used are Zipkin and Jagger. Also, Jagger has a connector for Zipkin, so you can basically use the same interface to export metrics to both of those servers. Okay, I will not go to details. We can see the most important thing, P99, how much requests can we how much requests we can serve with 99% availability. Then we get to spans. Span is basically connecting multiple requests. So when one request comes into our service mesh, we will generate some trace ID that will be propagated through all requests on the chain of calls in gRPC, and all of those sidecars will register that trace ID and export traces, so we can connect them after that. Okay, let's see how it looks. Okay, so here we have a request from Istio Ingress Gateway to Employee Search BFF, which then goes to knowledge and employee. So if knowledge for some reason failed, we can go there and check what we have in metadata. See which endpoint, which method was called, what actually failed. Also, we have request durations for each request, and we can use that to diagnose the bottlenecks and see what is taking too much time to process some request. Okay, the last thing, when Istio reports the metrics and traces and all the observability things, the metrics are sent usually to Prometheus. And with Prometheus we can use Grafana. Istio has pre-built dashboards for Grafana, so you can track CPU, but the main thing is that you can track things on multiple levels. You can track control plane level, what happens there. You can track workloads, your services, let's see, and you can see some interesting things here. The first thing is non-500 responses. We are all scared of that. We don't want that in our systems. But you can see the speeds, the encryption, duration of requests, etc. And we also have an Istio Mesh dashboard. It's like the overview of the whole mesh, where we can see something like a summary of our mesh. If we have problems in mesh, some server is failing, or we want to check the speeds, how much we can process, and things like that. But at the end of the day, you will need more complex dashboards to check which problem you have, or optimize for speed, things like that. Okay. Okay, let's wrap up this. I talked about gRPC and protobuf. I mentioned that it's high performant. It's much faster than HTTP, but anyway, you need to evaluate if it's a good fit for your applications, for your system. Also, the big thing in WCF, a lot of developers don't want to move from it, and you just need to evaluate pros and cons between those two technologies. Then we have a service mesh as infrastructure layer. It's a nice technology that allows us to, let's say, not develop infrastructure code in our applications. So we can outsource everything to DevOps and focus on business logic in our services. So meaning that we don't have authorization, we don't have authentication in our apps, no complex logging systems and things like that. It makes service mesh a good thing. And I am mostly connecting service mesh to gRPC because we use it and it's good with it. But you can also use service mesh with HTTP1 REST services. You will have some benefits, but you will not have speed of the gRPC, but you can still have MTLS on REST, distributed tracing, traffic management, etc. Okay, Istio's big features: traffic control, observability and security. We can do a lot of things with Istio. Routing is one big thing. We can manipulate routes, do URL rewrites, add headers, remove headers, manipulate the request itself. From observability standpoint, we have logs, metrics, and traces which help us mainly debug distributed applications, which is not always that easy. And for security, we have MTLS, which is the best thing that we get from service mesh because it's automatic thing. We don't need any manual setup for it. Okay, thank you all.
Okay, I guess we are ready for the Lion Talks session for the panel. So first, thank you again for the great presentations, great details, many things to learn. So the first thing I wanted to question, so I especially liked your first demo, the long one with WebEx failing down. So that was a great to show us how it's really unreliable and the infrastructure of it is really.
They should move to gRPC.
Yeah. I wanted to ask you when we are starting with the alternative, when we are implementing the alternative.
Hopefully they will start.
I think we start a new project.
Yes.
We have a great infrastructure for that, so gRPC.
We have, but we need to work on more on Azure services. Mm-hmm. So we cannot just throw our servers to the trash. Mm-hmm. So it's a bit harder to move everything to Kubernetes, mm-hmm. mainly, but it is doable and requires some effort from IT, DevOps, and probably from developers, but I think it's worth it.
Okay, thank you. So, do we have any question from the audience at this point? Not yet. So, I have few questions which we prepared and got from the online audience. So, the first one, what do you think about the performance during transcoding? So, is it something that we lost here? How much?
If we want to support browsers, we need to use it with gRPC. But I think that it will not affect much of the performance comparing to standard REST APIs. It is, let's say, a few milliseconds. It's very well written in C++, so it's high performance.
Okay, thank you. So another question with Istio. Did you find any issues with it in production?
I can remember one issue. It's nothing critical. The issue was with query parameters in get methods. It's actually URL encoding issue because Envoy cannot make a difference between plus sign and I think it's %20, and they have that issue, and the workaround is just add one config. But we got some false results. Let's say. Actually, we got a bunch of results, and we expected one.
Okay. Okay. So, have you tried any other service meshes besides?
No, but they are pretty similar. Most of them are relying on Envoy, so sidecar will always be the same. The control plane is different from implementation to implementation, but the main driver for us to go with Istio was gRPC transcoding, because Open Service Mesh, Linker, Cilium, I think, none of them have gRPC transcoding, and also extensibility that Istio provides. They are very close. You cannot add Envoy filters on the fly and things like that. It's a bit harder for our use case.
Okay, so basically, not the Istio popularity wasn't a factor in choosing it, but
no, we cannot choose that big technology just for popularity. We need to do some evaluation, but gRPC transcoding just cuts the thing. We need it, and we go for it.
Okay. And we have one more question. So, is there an easy way for a migration? Let's say if I have a WCF app and I need to migrate to gRPC, is there an easy way to do that?
Probably. I didn't try it, but there is a package called gRPC Reflection, which can take C# classes and publish gRPC service. Actually, it will dynamically create proto files on the fly and publish the service. So probably you can use that for data contracts. And also there is another thing. How is your business layer, let's say, written? Can you just plug another technology and make it work? That is also another thing that needs to be considered.
Okay, thank you. So, are there any other questions? No? Should we wrap up?
Well, maybe I have one question.
Okay, go for
I
it.
really liked this KIAD monitoring tool. Do you use it in production? So
Yes.
Is it reliable? So
Okay, so let me just repeat the question. So, This monitoring tool that you showed us on your second demo, yeah, Kiali. So did you use it on production and can?
That's the very good monitoring tool that you always want to have, because you need overview of the whole mesh. You need to know what's happening, and as you saw, it will show the requests in real time. It has animation of the requests. Also, that animation will get more dense on those graphs if there are more requests. So you can monitor a lot of stuff in there. Also, the great thing is tracing and logs. You have one tool for everything. So, of course, do not expose it to public internet. Make it on VPN or VNet with some management VMs, and I think that's the way to go. It's a pretty good tool.
Yeah, you have presented it and it looks very, very good. That's why I asked, because I do not know how it behaves under a heavy load, let's say. So if you are using it for production,
so the question is how it actually behaves on a heavy load.
The big thing is that it has nothing to do with a load. It is mostly relying on metrics that is exported to Prometheus, and distributed traces that are also exported to Jaeger or Zipkin. So it's just a UI tool to show you what's happening in the system. It's not going directly into the request pipeline and taking some arbitrary data. It's just, let's say, observer of the service mesh.
Great, thank you.
Thank you for question. Okay.
Can you try maybe WCF core? Maybe for example, if you are choosing the technology currently for your new project, so you have to choose between gRPC and WCF core. What will be the deciding factor?
Okay, so another question is, have you used WCF core, and what would be the deciding factor between choosing gRPC or WCF core?
I would never use
Okay.
core WCF because that's the real truth. It's missing some functionality that might be important for some people, but you don't get anything new with WCF, and the performance stays the same as before on WCF with full framework. So if you're starting a new project and need service-to-service communication, go with gRPC. And my opinion is that it's much simpler than WCF, because WCF comes with bindings and a lot of configuration which we don't need in gRPC. It's rare occasions when we need to specify message quotas or things like that. So go with gRPC on new projects.
Thank you.
Okay, we have another question.
Is there any kind of support in Postman or some other tools that you can use to find like readable code?
Okay, so the question is this support for gRPC in Postman or any other tool, so you can get the readable requests and responses, etc.?
Yes. First of all, Postman implemented gRPC requests, I think, a month or two ago. So it's still a beta feature. It's not fully supported. You cannot use gRPC streaming and things like that. But there is alternative called Bloom RPC, which is open source tool. It has a lot of stars on GitHub, so most of the gRPC developers are using Bloom RPC. Okay.
Thank you.
Okay. So, any other questions? So, if not, thank you everyone for participating. Thank you for being here. And hope you can still mingle with us until the rest of the evening. So, thank you very much once again, and see you on the next CodeTalks.
Yes.